Hello everyone. Today we are going to study the basic proportionality theorem, and it is also known as the Thales theorem because it is traditionally attributed to the Greek mathematician Thales. It is also known as the intercept theorem, but don't get confused with another theorem which is the same name. Now the basic proportionality theorem, the BPT in short, is an important theorem in elementary geometry about the ratios of various line segments that are created if two intersecting lines are being intercepted by a pair of parallels. Now it is equivalent to the theorem about the ratios in similar triangles. Now you can see here that four intercepts are formed by the parallels, and BPT is concerned about these four intercepts and its property. And we are going to study about the basic proportionality theorem here and its converse also. So the BPT states that if a line is drawn parallel to one side of a triangle to intersect the other two sides, interesting points, the other two sides are divided in the same ratio. So for that we need a triangle, and let's name it as ABC. So what is given to us is there is a line DE which is parallel to BC. For instance, we are considering BC for ourselves. We can consider AB and we can consider AC also, but the choice is ours. So D and E are the distinct point which is cutting the other two sides AB and AC at D and E respectively. So what the theorem says, or what we need to prove, is the two sides AB and AC are divided in equal ratios. That is, AD by DB is equal to AE by EC. So what the theorem says is, if the line DE is parallel to one of the sides, say for here BC, then AD by DB is equal to AE by EC. That is what we need to prove. And you need to see that these four segments are the segments that we are going to use as the base of four triangles whose area we shall calculate to prove this. And not actually four, actually three, because one triangle we are going to consider two times. That is the triangle ADE. In the triangle ADE, once AD will be the base, and the second time we will have AE as the base. So when AD will be the base, then we have to draw an altitude from point E, and when AE will be the base, then we will have to draw altitude from the vertex D. Similarly, we will have DB and EC also acting as the base of two triangles. But which two triangles? So let us see which two triangles. We will have to join BE and CD to get those two triangles. So when we join BE, we will have one triangle, and when we will join CD, we will have the other triangle. So BE joining gives us the triangle DBE, and when we join the CD, we have the triangle ECD. Now, before going to the next part, let us recall one concept. That is, if two triangles are lying on the same line and they have a common vertex, then their altitudes are same. Try to see the same diagram in our triangle ABC, where you will see that the triangles ADE and the triangle ECD have the bases AE and EC lying on the same line AC, and they have a common vertex D. So their altitudes will be same. So we will have dx as the altitude for the triangles ADE and ECD. Similarly, if you consider the triangle ADE and triangle DBE, you will have the bases AD and DB lying on the same line AB. and they have a common vertex E. Hence, EY will be the altitude for both these triangles. So now, since we have drawn two more constructions, dx and ey, we have mentioned it that dx is perpendicular to AC and ey perpendicular to AB. So these are the two constructions that we are required to do for this proof. So first, for the proof, we are going to consider the area of the triangle ADE. Then we are going to consider the area of the triangle BDE. Then we are going to consider the area of the triangle ECD. But remember, ADE, not once, twice. Once AD as the base and then AE as the base. So we have to prove that area of the triangle is equal to half into base into height, which we know. And hence the area of triangle ADE we can write as half into AD into EY. So where AD is the base. And notice AD is the first segment for the value which is in the ratio that we need to prove, AD by DB equal to AE by AC. And this time we shall take AE as the base. So when AE is the base, then dx will be our height. So these are the two equations that we get. Now we shall consider the blue triangle, that is triangle BDE, or we can say, so area of triangle DBE is equal to half of DB into EY. We have mentioned earlier why EY is altitude. And area of ECD is equal to half of EC into dx. Why dx is the altitude we have already discussed. So when we divide the first equation and the third equation, you have AD by DB because the halves get cancelled and EY also get cancelled. The first and the third equation have half and EY common. So when we divide them, they will get cancelled and only AD and DB will remain. So ADE by area of DBE is equal to AD by DB. Now we divide equation 2 by 4 and we have that area of ADE by ECD is equal to AE by EC. Same way as the previous one, the halves get cancelled and dx also get cancelled because dx is common to both of them. So now we need to prove the right hand side of equation 5 and equation 6 to be equal, that is AD by DB equal to AE by EC. Then we have to prove that their left hand sides are also equal. Now notice in the left hand side you have the numerators ADE and ADE in both cases, and since they are the same triangle, therefore their areas are also equal. So if we can make the denominators also equal, then these two will become equal. So what is the denominator? DBE, area of DBE. Which is area of DBE? The blue triangle. And area of ECD, the green triangle. So the blue triangle and the green triangle have the same base DE, if you can see, and they are between the same parallels DE and BC, and hence their area will be equal since they have the same base DE and are between the same parallels DE and BC. Hence we have the left hand side, that is area of ADE by area of DBE equal to area of ADE by area of ECD, and which will give us AD by DB equal to AE by AC. Hence proved. So that is our basic proportionality theorem, which says that if a line is parallel to one of the sides of a triangle, then the intercepts, that is AD by DB, will be equal to AE by AC. So what does the converse of BPT states? If a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. In the BPT, we saw that the line was parallel and we need to prove that the ratios were equal. In this case, the ratios are given to us to be equal and we need to prove that the lines are parallel. So we have our triangle ABC and what is given to us is the ratio which is equal, and since the ratios are given, so we have to consider the points D and E, and this DE gives us the ratio AD by DB and AE by AC. And you can see that I have not drawn DE parallel to BC because we don't know whether it is parallel or not. We need to prove that it is parallel. So since we have not drawn parallel, so there must be a line which is parallel to BC, which is passing through D. So we draw a line DF, which is parallel to BC. And we need to prove that this DE is parallel to BC. So this is our DF, which is cutting the line AC at F, and this DF is parallel to BC, that is by construction. And we need to prove that this DE and DF are the same line, that is, they are coinciding. Now you see that they are parallel, and hence by using BPT we can say that since your DF is parallel to BC, we can say that AD by DB is equal to AF by FC. Right, and that is our second equation. Now compare the first equation and the second equation. You have the left hand side to be equal, and hence we will have the right hand sides to be equal. In the left hand side we have AD by DB in both cases, so the right hand side A by EC should be equal to the right hand side in the second equation, which is AF by FC. Now we can directly use componendo to get the result, but let us see how we get componendo by adding 1 to it. So if we add 1 to both sides to the ratio, then the denominator, after taking LCM, gets added to the numerator. We have AE plus EC divided by EC, because EC is our LCM in this case, and in the right hand side we have AF plus FC divided by FC, where FC is our LCM. Now you notice that AE by EC in the diagram is AC. Similarly, AF by FC is also AC, and hence we have AC by EC equal to AC by FC. Now since the numerators are equal and the ratios are equal, therefore the denominators have to be equal, that is E and FC have to be equal. Now how can that be possible? That can be possible only if E and F coincides, right? Otherwise, there is no other way that it can be possible in the same line, because from C the distance of E and the distance of F is equal, and hence they have to be coinciding each other. So that means E should not have been in the initial position, E should have been here. So that means this line should instead be a line which is parallel to BC. So we can state that E and F coincides and DE is parallel to BC, and that is proved. But our diagram shall not be like this, it shall be like the previous one, where E will be placed in a different position, and we will be having DE joints, and we will also having another point F. This will be your diagram, and with this diagram we will be doing the proof. Thank you, and that should be enough for the converse of BPT. For any doubts, leave me a question.